Okay, great. So as said, I'm recording this meeting. So mute your mics just when you need to do that. The scale can be worked out this way. You first have to convert the units to the same units. So we can convert millimeters to meters. Oh, look at me. Okay, I'm back to it. Nearly lost that. Okay. Need my eraser. Okay. So let's convert millimeters to meters. That means we move the dots how many times? 3 times. 1, 2, 3. So the dots will be somewhere here. So 0.1532. Then we take off these dots. Okay. We can put a 2 here. Divided by, so now this is meters. Are you okay? 1, 2, 3. That's millimeters means 10 to the power minus 3. So 3,000 minus 500 will give us 2,500 meters. Okay, so now we have meters, and then we can cancel the meters out. Are you okay? And then we can now continue with our calculation, and we want to get 1 on top because for RF scale, the left hand side of the ratio should always have 1. So 0.1532 divided by 0.1532 all divided by 2,500 divided by 0.1532. So more or less it's like we are multiplying the top, the numerator by 1 over 0.1532, and we are multiplying the denominator by 0.1532. So we can literally cancel it out. Are you okay? And then still have what we had before. So the trick is to now cancel that. This cancels this. Then we get 1 up here. Are you okay? So 1 divided by, then you work the denominator out. So the person who is talking, whoever is talking, should mute their mic. Okay. Before I remove them from the room. Yeah. Okay. So Bright is not here today. So next week, who is not going to be around? 2,500 divided by 0.5. Let me use my calculator here. And so that gives you the scale. 2,500 divided by 0.1532. That gives you 16,300. So approximately, in fact, it will give you 16,318.53. But scale is always rounded. You don't have to write scale this way. RF scale should be written this way. So you want to approximate it to 16,300. Okay, or 16,500. Depending, I mean, you just want to get something approximate. Are you okay? All right, so your RF, the scale for this photograph is 1:16,300. Okay, so this is what I'm expecting you to do. Okay, and when we go back to the notes, in a question like this, you see that we're not really bothered about the formula itself. Like I said, our main challenge is how to get the scale on the right hand side, as you can see over here. Okay, our challenge is this bit. Getting that is where your challenge is. If you leave it like we have here, we don't want that. Are you okay? We want you to end up with scale as in what we have on the right hand side. Any question on this one? What I've just done? Let me have it. Otherwise, I think we move on. Last week, that's what we had a challenge with. Apart from that, we move on. Are you okay? Okay. Any question? I'm giving you just 2 seconds, 3 seconds. If you feel there's something that beats your mind, let me know before I beat your mind when I ask you a question in the exams. Is that okay? Do you have any challenge? Feel free. I'm not excited about the class and your attendance, but it doesn't mean you can ask a question. Is that okay? You can ask a question. Okay, so no question. Let's move on. We're going to talk about ground coordinates from vertical photos. Okay. Ground coordinates. So what are ground coordinates? So ground coordinates are like coordinates on the ground. I mean, I don't even need to what. So we can have the coordinates per the photo, okay? And you can have the coordinates, the corresponding coordinates on the ground. So I'm just going to overemphasize. Is that okay? So that we don't get confused. Ground coordinates are the coordinates that SMD, Survey Mapping Division, refer to when a surveyor goes to a pillar. Are you okay? And then they want to measure from it. They are set of numbers, usually very huge set of numbers. So X, Y. Are you okay? I believe you know this, but I'm intentionally, talking about it like as if you don't even know about it and never seen it before. Okay, so huge set of numbers. Okay, and then usually you can have a Z component. All right, so X, Y, and then Z. Okay, all right, so X, Y, Z, what does it mean? It actually means that you have a coordinate system that exists on the ground. So you can have a terrain. Okay, so I'm drawing the terrain in 3 dimensions. Yeah. So this is how deep it is, the ground is. Okay, and this is like the land. Okay, and then you can have trees on it. So there's a tree planted here in 3 dimensions. Are you okay? All right, so I'm just going to draw one more thing, like some kind of building here. Okay, so if this is a structure which is on the ground, okay, then we can refer to our ground coordinates as some kind of imaginary lines on the ground. So I can draw a line going through like that. Okay, another line going through like that. So we can have our X axis. We can have our Y axis.
Disconnected.
Then we can have, please, we don't want to hear you. Whoever is talking, we're not interested in what you're saying. Okay. So mute your microphone because we're not interested in what you're saying. Mute it. Something we're recording and then you are just like that. Okay, that's a Z axis. Are you okay? That gives us a height. Okay. So every object on the ground, we can actually estimate their ground coordinates. Are you okay? By measuring with respect to the X axis or the Y axis. So the ground coordinate for a point like this one, that's a bottom corner. This bottom corner of the building, are you okay, can have a coordinate. So we can give it an S coordinate, which is actually from the origin. So this is like the origin here. You have the origin. Okay. All right. So the distance we measure from here to here, that will be X. And this point, maybe XP. Are you okay? So from here to here is XP, and then from here to here is YP. Okay. All right. Now, what is the Z coordinate? ZP. So ZP is going to be with reference to a datum. Is that okay? So the datum is a reference surface. So the reference surface, we can just draw some dashes to represent it. Example of this datum is what we call the mean sea level. I believe you all know what the mean sea level is. Okay, so we can just do this and call that ZP. Okay, so that's for the bottom corner of the structure we are seeing. And then we can do same for all the points, possible points that can be captured for an object. So the top corner of that structure, building or whatever it is, top right corner, bottom right, far, northwest point. We can look at the bottom of the tree and get the coordinate for that. Are you okay? Ground coordinate for that. The concept of coordinate system is just a set of parallel axes, are you okay, which are also orthogonal. Are you okay? So maybe it's been a while since you saw that word, orthogonal. Are you okay? That means that they are at right angle, these axes, X and Y. Okay, in photogrammetry, the X is the flight direction, and then Y is the vertical direction. Are you okay? All right, so this is 90 degrees, orthogonal. That symbol means you're 90 degrees. And then the Z-axis is perpendicular to the plane defined by the XY axis. So you need two axes to get a plane. Are you okay? All right, so the XY plane, the Z-axis is orthogonal. Are you okay? To the XY plane. Are you okay? All right. The reason I'm doing all this because if you go back to the diagram, we're looking at ground coordinates. Now in this diagram, you can definitely see that the XY axis, let's go back to it. See at the bottom here, we see the X axis, capital X. Let me get my annotation. So you can see that this X axis is the flight line. So the aeroplane taking the picture is going in this direction. Are you okay? It's moving in this direction. It's going this way. Okay, and that's the X. That's how you define the X in photogrammetry. So when you see X, is a direction of flight. Okay, positive X. All right, so 90 degrees to the X axis, you get a Y axis. Okay, so you can see that we have the Y axis. Okay, over here. All right, now having established that, where is the Z axis? Definitely this, the plane defined by the SY axis is this one. See, this whole area is a plane. Are you okay? Defined at a particular level. Are you okay? At a particular height or elevation. Are you with me? All right, so let's take a point like this one here, point A. So point A is about HA, not about, is HA above the plane being defined here. Okay. All right, guys, we have 10 minutes to finish this session. When we're done, use the same link and join again. Is that okay? Join again. All right. The essence of a lecture is to really explain to you, but you can read all this by yourself. The materials are there. I think I've posted them to you, but it's you understanding it. That's why we do the lecture. Please, that's the only reason why we do a lecture, so that you understand. Okay. So that's by me. Okay. All right, go ahead and then determine what the height of A is above the datum. So from A from the plane, yeah, the reference surface, the level, to the point A, this distance is HA, okay? And this plane carries on, defined by XY, okay? All right, now what's the coordinates of point A? The coordinates of point A, okay, is XA, capital. Don't use small letter X. If you use small letter X, it means it's photo coordinate or image coordinate. So don't do this. This means you don't know what you are doing. Are you okay? All right. Now don't use capital HA. You see, he's using small letter HA. That means that it's not the flying height. So capital H is the flying height. All right. The coordinate of point A is capital XA, capital YA, and then ZA. Okay. But of course, it's because I'm writing this editor, this annotation tool cannot write subscript A. It's supposed to be subscript capital A. All right. Now, what is this XA on the ground? On the ground, XA is a distance along the x-axis from the point. Are you okay? So if you measure parallel to the x-axis, you get the XA. So this is the, let me try and draw this again. Okay, this is the x-axis. Okay, and this is the point A. So how far are we along the x-axis? How far is A along the x-axis? So that's going to be from here. Okay, let me get it to from here to here. We simply go along, sorry, from here to here. Okay, so from here to here, that is your x. It's the same as from here to here. Okay, so these two distances represent XA, okay, according to the coordinate system being used. So there are different coordinate systems. Are you with me? You can have a local coordinate system. You can have a national coordinate system. Are you okay? And usually, once we deal with XY, this is a projected coordinate system. Are you with me? A projected coordinate system can have shifts. We can have a shift in the coordinate system. Yeah, we've applied all the rotations. That's been the transformation. All right, the Y coordinate, YA, as you see in it, is actually from here to here. Same as from here to here. Same as from here to here. So for one single coordinate, same as from here to here, we can actually, you know, draw a box to define the coordinates. Going back to this. So we can draw the same box for what we see on the board. Okay, even though it's looking quite cluttered. Okay, I'm still gonna do it anyway. I'm gonna go for color black to do this. So we can always draw a box like this. To define this point. Okay, so this box actually is it represents the coordinate, the distances from the origin. Are you okay? So we can look at from here to here, x, from here to there. Okay. Okay. So that's actually referring to this point here. Okay. But if you want to refer to this point, then we have to reduce the box. Are you with me? So we shift the box. At the moment, the way I've drawn it is kind of pointing to this point. Are you with me? But that's the idea of coordinates. You need to pick, you don't just go to the ground and be picking coordinates from control points. Okay, Charlie, give me the coordinates for this point. You just start writing it down. Have something in mind that the coordinates are a distance from, okay, from a certain origin. Okay, certain origin. Okay, great. So basically that's that. When we take the photograph, then every image that appears on the photograph has it's actually of a certain object. Every image on the photograph represents an object on the ground. Let's look at point A. So point A is actually the image of ground point A. All right. Now where's the lens? This point represents the lens, the point up here. Sorry, it's trying to disappear, but I have to come back. Okay, there you go. Annotation. This point here kind of represents the lens, but this is just for mathematical, purpose, the mathematics, the analysis purposes. That's not the way a lens look like. Okay, we only representing it in terms of geometry. All right, so on the photograph, point A on the ground is smaller a, so coordinate on the photo is smaller x, okay, smaller letter x subscript a. Okay, right. So you don't write XA, that's wrong, that's ground coordinates. You don't also write XA, you actually write S subscript A, but I can't write S subscript A using this tool that I'm using to show you right now. Okay, so I want you to understand, once you get this, when you put down the formula, it's just very easy for you to calculate and understand. Are you with me? Now, XA is not fixed. Remember, there are thousands, in fact, there are infinite number of points that can be represented, captured in one particular film, okay, or on a photograph. Okay, so let me clean this. All right. This point A is only saying that, let's assume we have one point on the ground, it should be captured as point A. Okay, so we are going to end this session and we'll rejoin with the same link. Is that okay? Then we're going straight to the calculation and how it will be done. Okay, so we can have, I'm ending it on this one. I'm going to draw, I want to show you the possibilities that exist, because some of you get confused. The kind of answers you give in exam shows that you didn't even understand what it was all about. So let me take my time and do it for you. Is that okay? All right. I need a line here. Okay, so get this. We can have this possibility. 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 We can have, these lines could be going to different points, and you can draw like millions of them. This is the top of a mango tree. This is the top of a corner of a building. This is, a galley. This is the middle of it. This is the bottom of a tree. This is the bottom of a mountain. This, like, can you imagine the number of points you need just to define, okay, an area, a small area? That is what the point XA and smaller XA and then bigger XA represents. Okay, so